Start recording. Alright. So, that's OBS. So, like, this is where we left off from last time in our Unreal Engine game development stuff. And, this is, I guess we're basically just gonna be finishing up this project. With how it is, I guess I'll review what we did last time. So, last session, we kind of just set up this blueprint with our player. Not much. We literally just set up our movement by having these input axes, and we multiplied them by a speed value, and then we just added a force onto our cube. Very straightforward. How did we create these input axes and get like our keys and stuff? If you go to our project settings, once that opens, yes, then we can go to input, and then there it is right here, move vertical and move horizontal. And then we can just set our value for that too. So, you know, for moving vertical, we use W and S, and then moving up is positive, and moving down is negative. And
Oh, so
then,
it moves at constant velocity?
well, it's not a constant velocity, because, I'll get that in just a sec. Yeah. It's the value, like, the force that it's pushing at is constant, yeah, but it's not
Oh,
a constant velocity, because you're using
so the acceleration
forces.
is constant. Oh, okay.
So we're like constantly adding the force, and you know that's more like acceleration, not a constant velocity. And since we're also like adding forces, this deals with like the physics engine as well. So we also edited like our objects friction, which is the linear damping. It's basically just the friction. So you know how we move in game, we just kind of slide around like a tiny bit. But yeah, you can see it's a little smoother and whatnot. So that's just kind of how it is. So this time, or well, that's what we did last time. And also with this like small project, since we're looking at it from like this single angle, we're not really paying attention to where the camera is right now. I mean, we are, but we're mostly just paying attention to where we are on the coordinate axis. So you can see like the red arrow is our x-axis, and the y is the green, and the z is blue. We can just ignore the z for now since this is like kind of a 2D game. But you can see that the y is pointing downwards, and the x is pointing to the right. So the x is actually pointing in the correct direction, but the y is pointing in the opposite direction what we want. So that's why we put -1 in our move vertical speed here.
Oh, yeah, they're using a left-hand coordinate system.
Yeah, it's very weird. I'm not really sure why, because if we like flip the camera, then like, oh, y would be up, but x would be reversed. So there's no real way to make both positive. So we'll just go with this. It's just easy. You just multiply it by -1, and that's it. We don't really need this. I mean, there's just extra code left from some experimenting last time. So that's kind of all we really did. And then we just set our start location when we first spawned in, and that's kind of it. And this time, oh yeah, we also created materials. We messed with the material editor a little bit by putting in a color node into our base color, and that's kind of it. Very simple stuff. We're not really dealing with any of these nodes yet, so we can just deal with that later. But for now, let's get into making the enemy objects, which will basically just set the player to our start location. That's just kind of how it is. And yeah. Also, in case you forgot or don't know, our game is based off the world's hardest game thing, the HTML or JavaScript game. But that's why it's like super simple. But I just want to start everything off with something really simple. But yeah, so let's make those objects. So we'll create a new blueprint class. Then we'll just make it an actor class because these enemies can't really be controlled. So we'll just make it an actor. We'll just call it BP underscore obstacle, I guess. Then click save. Then we go into it. And then we'll just make these spheres. So we could, at the top left, we can go to add component. And then it'll bring up this little search thing over here. We just type in sphere. Bam. Done. Now we have a sphere. Awesome. Well, we can now drag in our sphere objects in, but you'll notice that they're also white. So let's make them a different color. So we can just right click again, create new material, call it m underscore obstacle, something like that. Save, open, create a color. Actually, we'll call it a vector parameter. Right here, we'll call this color. So we're creating a 4D vector for our color. We can double click this, and then we can just set the color to blue.
Wait, why is it 4D?
It's because colors usually in like 3D stuff use a red, blue, and a green channel for the color, and then there's the alpha channel for like
Oh,
the
transparent.
visibility. Yeah. So we can do like, I guess if you want to see like the alpha channel in action, we can set this to translucent and then put this into our opacity. Maybe let me set it to 1, see what happens. Oops. Click apply. Time now, I think. Oh, yep. So this is 1, so let's set it to like 0.5 and see what happens. If it's gonna take too, oh, there we go. Yeah, you can see it's see-through now. Wow.
Oh, that's really cool.
Yeah, so you can do a bunch of like cool stuff like this with the material editor, but we'll just make it basic for now. We can always delve into all of the different nodes later on. Let's save. So yeah, we have our material for our obstacle, and all we really have to do is that we drag our obstacle window out, and then we look for our material here, and then we drag this in, and then now it's blue. Wow. Okay, so how do we make this thing move, I guess in like an up and down sort of direction? Very simply. Well, you see I have kind of a technique that a lot of people basically use for like moving platforms and stuff, and like platforming games and whatnot. So we will use the tick node, and then we will drag out of the delta seconds and put that into a multiplication. So all I really did was drag this out, and it creates this little window. I put in a star and just clicked float times float. This makes a multiplication node. Then I can drag this out and type in the sine. So we'll use the sine in radians because the sine in radians returns a number between -1 and 1 always. And we can use this to our advantage. So then we can drag this out, bring in another
Uh,
multiplication node.
but sine in degrees also returns between -1 and 1.
In degrees?
Yeah.
No,
This
if
is the
you drag
input,
it out
right?
in degrees, it goes from 0 to 360.
Oh, that's the input, right?
Uh, the input, what, for sine in degrees?
Yeah.
No, the sine in degrees should return, um, just if you input like, no, because if you input, oh, I guess so, actually. Yeah, I guess it's actually true too, but I guess we're just going to use the radians though.
Yeah,
Yeah,
because we
you
need
are
a
right.
really large value for degrees.
Yeah, it's just different though. So we're doing radians. And we will just do, well, we will get the time since the game started. So time in seconds. And it should be here. So this time in seconds node just, well, gives us the amount of time that basically occurred since the game started. So that's basically it. And we will multiply this time in seconds by how far we want things to travel. So we will drag this out, and then we will go to promote to variable, and then we can just put in a length, or call this variable length, and click compile and save. So so far we are getting our delta seconds, which is the time between each frame of the game. We are multiplying these delta seconds by the sine of how much time has passed times our length in which we want our thing to move at, basically. Like how big its revolution is, I guess. You'll see in a sec how it works.
Oh,
Yeah, because I guess, or I'll get into the specifics once I show it off, but so we'll drag this out here, and we will also add in the speed of what we want to move at. So I'll go here, add another variable, call this speed,
yes,
compile
the
and
angle.
save.
Oh, so that's the angular frequency?
Oh, can you see the left over here? Or
Yeah, I can see it.
okay, yeah. So we could set our variable name over here. We'll set the value later on. So once we have this set up, I'll start setting the values to that. And then we'll finally drag our execution node out. And then we'll just do add actor local offset here. And then we can right click this delta location and do split struct pin. And then this makes that vector. We can do recombine again. So this is essentially a vector. This takes in a vector component, but we have a float, and we only want to move on one axis. So let's just split the struct pin, or split the vector into 3 different nodes instead of only being one node. So that's why I did the split struct pin, and we can just plug in our equation into our x value here. We can compile and save here. Or actually, let's make this the instead of the x, we'll make it the y. Actually, my bad. Because the last time I had it set up was kind of weird, but this time, since it's trying to go up and down in the y direction, we'll plug that into our y node here. So,
Yep.
and that's kind of it. This equation is kind of complicated. It is pretty confusing, especially with knowing how sine works, but I'll get into that in just a sec.
It would be a lot easier if this was in C++.
Yeah, totally. I know this looks pretty weird because blueprints are just weird, but
Yeah, it's like reading from right to left.
basically. But we'll get it. I think hopefully we'll get into the C++ today. We'll see. Okay, so now let's just set the length. I guess I can set the length to something like 5. And then I can set the speed to something like 3 and see how that works. And save all. Oh yeah, I forgot to explain what this node does here. So add actor local offset. All this really does is that it constantly adds a vector in a direction. that's kind of
so it's
it.
offsetted.
Yeah. We used this last time in the last tutorial. When I was getting movement down, I used this node as well. But we said it was bad because you can go through walls with it, but we don't really need to worry about walls with these projectiles, so we're just going to use it here. But yeah, if we click play, it should, or oops, my bad. That doesn't do anything. Here, I think we have to set the speed value maybe to something like 10. And I can set the length to maybe something like 100. Let me see, I forgot what I did last time. And it's not moving.
Sebastian is here.
Oh,
Oh, he left.
wait, he keeps like joining and leaving.
He's trolling us.
I didn't want to drag me out.
Wait, really?
Yes.
No.
I finished my ray tracing homework for
Nice.
today anyway, finally.
Nice. I think I have to do a speed of like 1,000. Let's see how 1,000 works. Oh, that is way too quick. Let's do like a speed of like maybe 400. And we'll do a length of maybe 500 and see how that works.
Oh. So you're multiplying the length by the time and putting that inside the sine?
Yeah.
Is it
So
supposed to
how
be
it
the
works,
opposite?
huh?
Like, aren't you supposed to multiply it by the speed inside the sine and the length outside?
Well, I mean, in the end, we are kind of multiplying everything, but multiplying the length and the time before the sine, I guess it makes it so this affects like the rate, I guess, because we're getting the time in seconds, right? So this is going directly into the sine value, and this is like the rate at which we change from 1 to -1. So essentially, like, depending on our value between 1 and -1, this is going to add to our local offset, right? So by
Yeah.
changing the length value, if we change the length value to like a very like low number, it's going to make the rate really slow, right? It's going to, because we're I'm trying to think
Oh,
here.
okay.
Yeah. I don't know if you really get it. It's kind of hard to
So the
explain.
speed is the amplitude and the length is like basically related to the period.
Yeah.
I thought it would be the opposite. That's why I was getting confused.
Right. Yeah, it's a little confusing, but as long as you just like kind of split it up into like sections here, where it's like, okay, so we're trying to get like the amount of time we are reaching between 1 and -1. And then we're multiplying this by a value to get our rate. And this affects how long we're going to travel in one direction and how long we're going to travel in another direction. That's basically just kind of it. It's really weird. But once I get the value here, let me see what I did with my other setup, what values I used, because these values are pretty good. So I did 2 and 1,000. Okay, that's fine. So 1,000 and 2. So let's see how well that works. Oh yeah, that works fine. So you see it's moving back and forth now. And I can edit the value. So if I increase this length value, so I'll increase it to like 5.
It'll go faster, you know?
Yeah, it should. You see how it makes the length a lot shorter now.
Well,
So
I mean,
that's
that's what the
basically.
speed
You're
was
just
the
setting that to
amplitude,
the
though.
x coordinate to move it in the sine wave?
Yeah, basically, or on the y coordinate, yeah. So if I set the length, it's still the same speed though. It's just oscillating at a much faster rate. And I can change the speed value here to like 2,000. And it's still going to be the same length, but it's going to go faster here. Or, well, actually, it won't be the same length, but we're actually traveling at a much faster rate, so it makes the length bigger.
Oh,
But yeah,
That x that goes into the sine, why does it have two inputs, length and get time seconds?
length and get time seconds here.
Yeah.
So here basically this just like affects our length, and this so like it's hard to explain, but we're essentially getting our time in seconds and then putting that into the sine value. And then since our time is constantly increasing, it's going to return a value between 1 and -1, right? When we input our time into sine.
Yeah.
So we
I get
want
like why
to,
sine's oscillating like that, but like I wasn't sure like why you use the x instead of like putting get time seconds directly into sine.
oh, it's just because I wanted to like make it so I could edit the like, I guess the
Oh wait, is that
length.
multiplying the two together?
Yeah, that's what x does.
Oh, okay then.
Yeah,
I
it
thought
just
x was like a
changes.
variable.
No, it just changes the rate at which we're switching between 1 and -1 here upon plugging it in the sine. But
Okay.
it's like kind of off though, because it doesn't really, because if you change the speed here, it's gonna, it's gonna make the value bigger because we're going at a higher speed. So we're still going at like the same length. So it's actually like not entirely true.
Yeah, but I
And
think
like
that
does length change the like distance traveled?
no,
uh
Or is it just like a second speed modifier?
it
omega.
changes the rate at which we're oscillating at. So it doesn't necessarily mean length. It just means the rate at which we're switching between switching directions at. And then our speed is our, rate at which we're actually like moving, I guess. So I can set the length to like 10 and we should move back and forth way quicker, right? But if I increase my speed, it's going to be the same oscillation rate, but it's gonna look bigger though because we're going faster. So you see it's still moving at like the same oscillation rate, but we're moving faster this time. But the
Yeah,
sine wave is
Yeah.
bigger. So it's not necessarily length. I guess it's length between, like, I guess we're kind of just stretching out the spring, if that makes sense, or we're squishing the spring.
maybe just call the length something else like angular frequency, and then the speed something else like amplitude, and that would make it less confusing.
That's true too. I just tried to make it simple, but yeah, we can do that too. Amplitude.
Alright, I'm gonna head back.
Okay.
Also, you flame me for like always joining the private channels, but I just realized you did that, Sebastian.
Wait,
Uh,
I had to do it to bait Royce to get in.
wait.
Yeah.
Wait, what'd you say for the
Oh, angular frequency?
angular sequency?
I think he meant that for length
Frequency.
though, right?
Yeah,
so
I'm
length
renaming length
should
right
be the
now.
angular frequency.
I'll just do angular frequency. Whatever. I don't know. Try to make it pretty simple, but that's just it's fine. Same thing, but that's our explanation on sine waves. But it still makes it way simpler than usually what people do between switching back and forth. But yeah.
Oh, do they also have other kinds of waves like square waves and stuff?
Like what again?
Like a square wave or like a triangular wave?
I mean, you'd probably have to calculate those. Well, I wouldn't say by hand, but you could essentially do those, yeah, if you like know the particular equation for it. Sure.
Oh,
Yeah. I'm pretty sure you can. Like, there are all sorts of math functions in here. So anyway, that was our explanation on sine waves. Confusing as shit, but it's just good for these because I'll actually show you some other cool things you can do. So let's just set our value to like 2, our frequency to 2, and then our speed value to like, our amplitude to 1,000 here. Then we should have like a pretty, okay, that might be a little big. So let's set this to like 4 and see if that Makes it not as
Oh,
big.
so basically,
looks
like
good.
whatever you set your angular frequency, if you divide it by 2 pi, that's the amount of time it takes to like go complete one full cycle.
Yeah, essentially. Well, can't you
Yes,
divide it by 2 though?
not 2 pi. So like this angular frequency, like so like if you set this to like 6 or like 6.5, then it will take approximately like 1 second to like go to make one full cycle.
Right. But, you know, it doesn't really matter. Like, we don't really need the ultra specific times unless we're
Yeah.
doing some crazy stuff or very particular things. But
Yeah.
yeah, I get you though. So once we have that down, we can make it so when this ball contacts with our player, it just sets us back to the starting location. And wow, how do we do that? Well, all we really have to do is that in our blueprint player, we just right click and then we do, actually we don't right click. We go to the cube over here to the left, we click on it, scroll down, and then we can go to the right over here and do on component begin overlap. So inside this cube, when we overlap another actor, we can get the class of it. Get class. So we're getting the other actor's class, and we're going to return it, and we're going to equal it to something. So we're going to check and see if what, class this actor is. And we're going to search up BP underscore obstacle right here. And this is the thing that we just created. And then this will give out a Boolean statement. So we just drag this out and we type in branch, and bam, we have a branch node. So branches are basically just if else statements. So if it's an obstacle, then and we collided with it, then we literally just drag this out, set actor location here, and then we're just going to set our actor location to our start location, and bam, that's kind of it. Remember, make sure to save. Oh yeah, one last thing to do with these obstacles is that let's go to the sphere and disable its blocking collision. So right now the sphere's solid, but we don't want to make it solid. We actually just want to make it overlap things. So we just do overlap all, and that should be fine. And then let's see if that works. So we're gonna move, and then we're gonna bop into this. Oh, what?
So
What?
like where are you telling?
That's how it worked in the test too, but unless I actually need, it's just not firing it for some reason. Yeah, that's really weird. Okay.
It's ISD.
This hopefully does something? No, still? Okay. What is happening? I don't know, this is very strange. It just doesn't work. What? Yeah, I can print something. Let me just try printing. Wait a minute.
It's not printing.
No, it was printing. It
Oh.
printed the player. Why is it printing the player itself? What the fuck? Okay. Huh. This didn't happen in the test. Okay. Now let's see if this works. Okay, now it's actually printing out the obstacle. No, it doesn't, even though it's printing out the obstacle. Okay. This is like actually derpy now. This is PhD level material. Wait, it's printing it, but it's not setting our location. Returning true? What?
Okay,
What?
so
What?
let me
What?
copy the location. What if Mozambique and Peach? Oh, okay. What? What happens if you cheat and like pull out your gun here?
Oh no! No! No!
Okay. Oh, no, it doesn't work. Okay, and oh, nothing. Has to have what? Please do anything. Oh, yeah. What?
Whoa.
Wait. We successfully made a spring.
Okay.
Let's go. Okay, so we know that works. So like, why doesn't it set the fucking location? Like, after fucking 30 minutes of figuring out this weird shit, we finally got collision to work because Unreal hates me. Okay, so we figured out the solution as to why the projectile wasn't, our player wasn't snapping back. It was a very weird phenomena that was happening, but we'll remove this junk that's out of the way. So, basically, right? Basically the same thing that we had, except we're just using the event, actor begin overlap. And then on this overlap, all we're doing is that we're getting the class and we're seeing if it's an obstacle, right? And then if this is true, we're going to set the world location of our cube, because that's the thing that we're directly controlling. We've been adding our force to the cube and everything, so on and so forth. I think it's because we were simulating physics. Oh, I think I actually know why it wasn't working.
Why?
I think it's because when we were simulating physics, our cube wasn't set as our root component. So when we're like adding our force and stuff to the cube, it actually detaches from the scene component. If you want to simulate physics with objects, you actually have to set the root component as the physics object itself. So I can actually get rid of the scene component. I think that's why it didn't work. It's because we were trying to set the actor location back, but the cube wasn't attached anymore since it was simulating physics. If that makes sense. So that's why. So, in the end, set our cube to the root component, and that's why it didn't work. But now we did, and now it should actually work. I actually think this should work too, honestly. We'll try it again. If it doesn't work, then we'll go back to the other solution. But so we'll do that. And then with this, let's set our sphere actually to our root component as well over here. So we set our sphere to our root component, and then we also set our cube to our root component. We can ignore that camera component. So we should be able to go into it.
I bet 10 cents it will work.
And yeah, it did work. So that's why. Okay, so that was strange. That was the strangest stuff, but it works.
Indeed.
So that's why. And I only know it is because I was messing with ragdolls, right? And when you simulate physics with ragdolls, it actually detaches from the object itself. So that's why it didn't work. That was just a very weird thing, but now we have it working. So just make sure your cube is set to the root component and your obstacle is set to the root component as well. Or well, I guess for the obstacle it doesn't matter, just mainly for the player. Okay. So since we have this stuff done, we can now just place a bunch of obstacles everywhere. And we want to be able to make these obstacles down here have a, smaller, restitution, whatever it's called, the length at which they move up and down at, because it's a smaller space. So we can actually just go into the obstacle blueprint itself. We can go into the angular frequency and amplitude, and we can do instance editable and expose these on spawn here. So now that we expose those on spawn, we can click on a sphere, for example, and we can edit the default values over here. So let's set the restitution of each of them. So we'll actually shift click all of them. And we'll set it to, I guess, a value of 2 should work. We'll see.
Oh, it will go really fast then.
Okay, actually maybe, yeah, my bad, not a value of 2.
The amplitude.
Value of 8.
If you want to.
Yeah. There, that works. Maybe like a value of 7 should be okay. Yeah, that looks okay too. Or 6. Whatever works. That works. Okay, cool. So now we basically set up our different things. And also, if you want to have like an orb move in the opposite direction of other orbs, we can just edit the amplitude and just set it to a negative value. Yeah. And save. And there we go. So now we have our orbs moving in different directions. We could also do some cool stuff actually with the orbs too. Like, for instance, if you want to have them go in a circle or kind of a circle, a cool thing we can also do is that we can
cosine.
Well, yeah, there is yeah, we can add in the cosine function here. But we can also do this too. Add local rotation here.
Ooh, that's cool.
And then we can do a value of 5. And this should make a cardioid, I believe. Yeah. So you can have a move.
Wow.
But yeah, the other one's kind of moved away, but we just have to edit the values in these ones. There. Or, my bad. Here. So, yeah, they'll move in like a cardioid if we do this. But if you want them to move in a circle, then yeah, we have to do the sine as well. And I think we can just literally copy paste this and put sine.
I mean cosine, yeah.
Or cosine, my bad. Cosine.
And that would be in the other
Radians.
component.
And we have to put it into the x. So we actually need to copy this. Here.
But are these variables still the same, like the amplitude and angular frequency?
Yeah, it's just that we need to, well, we're still referencing the amplitude and angular frequency, but we're just referencing them from a different node. Its blueprints are just annoying.
Yeah.
So you have to, you're like kind of forced to do stuff like this. Do world delta seconds. But I'm gonna like recode everything in C++ later too. So there.
Yeah. Might make more sense to call amplitude radius this time.
That's true. But this is only just for a quick demonstration, and it should be circles.
Ooh.
Yes. So yeah, you can do stuff like that. And now they move in a circle. But that's pretty complex. So we'll just keep it simple. We'll just keep it up and down for now. So we basically have like 90% of the game done. So we have our obstacles, great. Now, all we really have to do is add an end goal. So, and we actually, I guess, want to add like multiple levels too. But we'll just make it so we'll go to like a second level. And it's actually should be pretty easy as well. So let's just duplicate this level and it'll just be level 2. We'll go into the level and then we'll just like edit this in some way. I don't know, I'll just like rotate these 90 degrees. Okay, great. So this is level 2. So how do we make it so we go from level 1 to level 2? Well, it's... Huh?
Oh, another event in collision?
Yeah, we have to make a new object first. So we'll just call this the BP underscore finish here. And then go here, create a cube, and then make this bigger. here. And then give it a different texture. So I will create a new material, m_finish, done. And then make the vector parameter again, color. Oh, that is capital O. And then we'll just do green here.
Let's go.
Yellow. Or wait, our start is already green though. We should probably make this yellow, actually. My bad. So we'll make it like a yellowish color. There, that works. Sure. And we'll save. Make sure to save because Unreal's dumb sometimes. Then we'll drag out our finish. And then drag these in. There. Okay, cool. And we'll just drag in our finish here. So we don't really need to do anything with the finish line. Or actually, we should, yes. So, how do we, I guess, make it like get a list of like levels between level 1 and level 2? Well, we can actually do this pretty simply by creating something called a game mode. So we can right click, and then we can do blueprint class, and then we can do game mode base. And then what do we want to call this? We'll just call this BP_my game mode, I guess. Or new game mode. There. Cool. And this game mode is basically just going to hold an array of levels to travel between. So let's just create that then. So let's create an array, or let's create a variable. And call this levels. And then we will do, we'll make these a string levels. And then how to make this a variable, an array, is that you can right click it. And then it makes it into an array of strings now. So we'll get the levels array. And then we want to add in a list of our level names. So actually, we don't even need to add this in right now. We can just click on the levels here, and then on the right, we can do add element. So we can add an element, and what's the name of our first level? Well, it's level 1. So we'll just type in level 1, right? And then for our second level, we'll just do level 2, and that's kind of it. So that's pretty much all we have to do with the setup. Now we just need to okay, yeah, that should be fine. Okay, so now we just need to go into this BP_finish and make it so when the player runs into it, it just goes into our game mode object and it looks in the levels and it basically goes to that specific level that we put in this array. That's kind of it. It's pretty simple. So actually also first off, inside of our BP new game mode, we should set the default pawn class to none, by the way. So because like for some reason Unreal has like these default pawns that you can automatically possess, and you don't really want to mess with that for now since we set this object to be automatically possessed anyway, so it's fine. Let's see. So let's just make it so we have another actor begin overlap, and we can just get our other actor. We can get the class, or actually we don't even have to get class. We can just do equals equals. And if this object equals our player pawn object, so we just have a get player pawn node, and then we just do other actors equal to that. We'll just do a branch statement here. Bam, done. And then so once this overlaps, we will one sec. So we will get the game mode. So right click, get game mode. And then we want to be able to, so this is going to get the game mode, but it's going to return it as the base class of, whatever this game mode object that we made is based off of. So we want to cast it as our new game mode object that we created. We want to get this, we want to get everything added in here. So how do we do that? Well, we just drag the node out, and then type in cast, and then we can do cast as the BP underscore new game mode that we created. So now this game mode reference is going to be treated as our game mode object that we created. And now we can access things like our string array and stuff. That's basically it. Okay, so we casted it as our new game mode, and we can drag this out, and we can get that levels array that we created. And bam, now we can get our levels. So once we have that, all we have to do is that we have to, we want to get our current level. So we want to basically go to the next level that's after our current level. So what we would do is that inside of this array, we would do find item. So we would try to find an item in this array. And then how do we get the current level name? Well, we can drag this out, get level. So get current level name, bam. And that returns a string, perfect. So we just put that in there, cool. So now we found the index at which our current level is at. So we just drag this out, and then we can just do find, and then we just do find plus plus there, or not find plus plus, or actually yeah, there. So we're finding it, and then we're going to increment by 1. That's basically it, because it's the level after our current level. Then we will actually, that's basically it. So let's first just we'll set our current level name now, or we'll set the level that we're going to as this level that we just accessed from this array. So we'll right click, do open level, and we'll do open level by name. We'll drag this in here, right? So let's just so it's going to ask for the level name. So how do we get this? Well, since we found our index, we found our index from getting our current level and then getting the level after that level, all we have to do is just drag this out and do a get. So this gets a copy at an index of an array, and then it's going to ask for an index, and we just plug that index into here. And then we just plug this into here. Bam. And that's basically it. So now all this function does is that it gets our current level, finds it in our level array, gets the index at which it's at, and then gets the next level. And then we get the name of our next level, and then we open that level. That's kind of it. Are you still there, Anj?
I'm still here.
Okay. Yeah, it's a bit repetitive, but hey, it's what works. And another thing to check though is that we also want to check and see if this level is out of bounds of the array. So we should also make it so that if this is greater than or equal to the level's length here, so we'll plug this in. So we also want to see if our next level is in bounds of the array, because what if it's, the the last level of the game. We want it to go back. So we're just going to make it so it's going to go back to the first level. So we'll just do branch here. We'll create a if-then statement. Drag this in here. So if the level that we're currently getting at is less than the length of the array, then it's going to open the next level. However, if it's greater than or equal to, then we'll just open our level 1, or we'll open whatever's at the first index of this. So we can copy this, plug this in here, and get our array, or I'm sorry, copy, put this in here, and now it's getting all funky, but hey. Then we're just going to get the level name at index 0. Now this looks very weird, but we could just spread these nodes out just so it looks a little bit better. It's just blueprints are pretty hard to manage. Let's move this here, move that there. Yeah, so that's basically it in terms of how to do it in blueprints. It's a very simple function. We're just, getting a level after it, checking to see if it's in the bounds of the array. If it's not, go back to the first level. If it is in bounds of the array, then do the next level. And that's it. So let's test this out. Or actually, yeah. So we open levels and everything. So this should be good. And it looks like we have everything set up. Oh yeah, also we want to also set the right game mode for each level when we're starting it out. So we can go to blueprints, then we can do world override with the game mode, and we can just set our actually I think we could just set it in project settings up here too, and we can set our game mode to the one that we just created. Okay, actually maybe it has to be in here. Just kidding. Let's see. Yeah, there we go. BP_game mode. Product settings doesn't allow you to do it, huh? No, it doesn't. Okay, so you have to do the world override. Then we set the game mode to the game mode that we just created, which is the BP_new game mode. And we also have to do that in level 2 as well. Right here. Okay. So, let's just put our player in front of this right here and see if that works out. Oh, wait, shit. I need to put the start location, my bad. And then we'll move this here. Okay, so we have our player set here, and it doesn't overlap. Make sure this is set to overlap all. There we go. Okay, so there. Now it goes to level 2. So, yeah, just make sure the finish object is also set to overlap all, because if it's set to block all dynamic, then it's just going to block you from going inside of it. So, yep. I don't know. And that's basically it.
That was pretty smooth.
Yeah. Boom. Done. So yeah.